Hello everyone. On this video we will be looking at the sum and difference formulas for cosine. Okay, so for cosine of a plus b, we have cosine a times cosine b minus sine a times sine b, and cosine a minus b equals cosine a cosine of b plus sine a times sine b. Okay, so for our first example, we're going to compute the exact value of cosine of 105 degrees. Okay, so first thing we're going to do is we're going to get that 105, and we're going to make it something a little more familiar on the unit circle. Okay, so if we look at it this way, 105 degrees is equal to 135 degrees minus 30 degrees. Okay, so if you look at your unit circle, move that here, just cover that just for a second. If you look at your unit circle, you can't find a 105 degree, but you can find a 135 and a 30. Okay, so it's a little bit easier to work with. Okay, excuse me. So we have cosine of 105 degrees is equal to cosine of 135 degrees minus 30 degrees. Okay, so this is our A, and this is our B. Okay, so we know that cosine of A minus B is equal to cosine of A times cosine of B plus sine of A times sine of B. Okay, so that means cosine of A is cosine of 135 degrees times cosine of B, so times cosine of 30 degrees plus sine of A, that's sine of 135 degrees times sine of B, just sine of 30 degrees. Oop, ran out of room there. Okay, so we know that cosine of 135 degrees is negative square root of 2 over 2. Cosine of 30 degrees is square root of 3 over 2. Okay. So plus sine of 135 degrees is square root of 2 over 2. And sine of 30 degrees is 1/2. Okay, so if we simplify each term, square root of 2 times square root of 3 is square root of 6. So you have negative square root of 6 over 2 times 2, which is 4, plus 1 times square root of 2, square root of 2 over 2 times 2, which is 4. Sorry about that. Okay, now since these have like denominators, we can combine them. Okay, over the common denominator of 4, this is negative square root of 6 plus square root of 2 over 4. Okay, and that is our exact value of cosine of 105 degrees. All right, so if you are still writing, of course, feel free to press pause and finish up. We're going to go ahead and move on to our next example. Okay, so what if we wanted to compute the exact value of cosine of 7 pi over 12? Okay, so first we have to rewrite that 7 pi over 12 to values that are a little more familiar on our number line, or on our unit circle. Okay, so if we note, if we have 7 pi over 12, we can actually make that 9 pi over 12 minus 2 pi over 12. Okay, so 9 pi over 12 simplifies to 3 pi over 4, and pi over 12 simplifies to pi over 6. Okay, so again, two values that are a little more familiar on the number, keep saying number line, on the unit circle. Okay, so we have cosine, again, of a minus b equals cosine of a times cosine of b plus sine of a times sine of b. Okay, so we know here we have cosine of 3 pi over 4 minus pi over 6. This is your A, and this is your B. Okay, so cosine of A is cosine of 3 pi over 4. Cosine of B is cosine pi over 6 plus sine of A, so plus sine of 3 pi over 4 times sine of B. So that's times sine pi over 6. Okay, so we know cosine of 3 pi over 4 is negative square root of 2 over 2. Okay, cosine of pi over 6 is square root of 3 over 2. Plus sine of 3 pi over 4 is square root of 2 over 2. And sine of pi over 6 is 1/2. Okay, so we go ahead and simplify each term. 2 times square root of 3 is square root of 6, so we have that negative square root of 6 over 2 times 2, which is 4, plus 1 times square root of 2 over 2 times 2, which is 4. Okay, so we go ahead and simplify it by combining those because we have the like denominator. We have negative square root of 6 plus square root of 2 over 4. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. All right, so for this one, let's say if cosine of A equals 12 over 13, where A is in quadrant 4, and cosine of B equals 5 over 13, where B is in quadrant 1, find cosine of A plus B. All right, so first thing we are going to do is draw our little XY axis. Okay, so we know this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Okay, so we know A is in quadrant 4, so that means this is your right angle, and this is your theta equals A. Okay. Now, just from the information, we know that cosine of A is 12 over 13. Okay, but we also know that cosine is equal to adjacent over the hypotenuse. Okay, so for this angle A, your adjacent is 12, and your hypotenuse is 13. Okay, which means we have to solve for our y. So we use the Pythagorean theorem. So x squared plus y squared equals z squared. Okay, so your x is 12. So that's 12 squared. Oh, I meant to put the parentheses on the outside. It doesn't really matter, but I like to stay consistent. Plus, we're solving for y equals 13 squared. Okay, so we have 144 plus y squared equals 169. So if we subtract 144 from both sides, we see that y squared is equal to 169 minus 144, which is 25. So if we square root both sides, we say that y is equal to either positive or negative 5. Okay. Now which one? Well, it depends on the quadrant. If you look in quadrant 4, since it's below the x-axis, your y is negative. Okay. So since y is negative in quadrant 4, we know that our y is going to be negative 5. So this is going to be negative 5. Okay, so now we look at quadrant 1, which is our b. Okay, so I'm just going to move this 12 down here so we can clear up this one. Okay, since b is in quadrant 1, and again, it doesn't have to be perfect, of course. This 12 would be longer than this value here, but we're just trying to get something to help us visualize. This doesn't have to be visually accurate. Okay, so we can look here, and we know that cosine of b is equal to 5 over 13. Again, which is our adjacent over hypotenuse. So if this is our theta equals b, that means your x is your adjacent. So in this case, it's 5. Okay, our hypotenuse is 13. So again, we have to solve for our y. Okay, so we use our x squared plus y squared equals z squared again. Okay, so for b, you know our x is equal to 5. So that's 5 squared plus y squared, because we still have to solve for our y, is equal to our hypotenuse squared. Okay, so 5 squared is 25, so we have 25 plus y squared equals 169. So we go ahead and subtract 25 from both sides. I can erase that. Those cancel out. So we have y squared equals 169 minus 25, which is 144. So if we square root both sides, we see that y is equal to either positive or negative 12. Okay, now which one depends on the quadrant again. We see in quadrant 1, your y is positive. So we know that in quadrant 1, y is positive. That means that y is equal to positive 12. Okay, so we know that this y is equal to positive 12. All right, so we're going to scroll up back to the top because we're solving for cosine of a plus b. So cosine of a plus b equals cosine of a times cosine of b minus sine of a times sine of b. Okay, so they gave us cosine of a and cosine of b. Okay, so cosine of a is 12 over 13. Cosine of b is 5 over 13. Minus sine of a. Remember, sine is opposite of hypotenuse. So for a, your opposite is negative 5. Your hypotenuse is 13. So it's negative 5 over 13 times your sine of b. Remember, that's again opposite over hypotenuse. So you have your opposite, which is 12, and your hypotenuse, which is 13. Okay, so we have our 12 times 5, which is 60, over 13 times 13, which is 169, minus negative, so this becomes positive. So you have 5 times 12, which is 60, over 13 times 13, which is 169. So we have our common denominators. So our answer will be over 169, so it's just 60 plus 60, or just 120 over 169, which is the value of our cosine of a plus b. Okay, so hopefully this makes sense, and I'll see you on the next video.